Alright, Math 3, let's practice some sine and cosine, some graphing. Okay, so these first two, we're just simply doing the parent graphs. And remember, we like the amplitude and the period, and even the midline. Okay, if we find those, then we can graph them. So, in the parent graph, for both, the amplitude is 1, the period is 2 pi, or if you're dealing with degrees, 360. And the midline is 0. So our midline starts here on the x-axis for both of them. Okay. Then remember, for sine, we start on the midline. Whereas cosine, we start above the midline on the amplitude, which the amplitude of 1 put us up here. Then, both sine and cosine, their ending is on the same as the starting. So for the sine, we end at 2 pi on the midline. 2 pi because that's our period. For cosine, we end at 2 pi and 1. Okay. Then we go in between, and it's for the sine, it's still on the midline. For the cosine, it's the opposite, so it's below the amplitude. Okay. Then for the first, between the first and the middle, for the sine, that's when we finally go up. Whereas with the cosine, that's where it hits the midline. And then for cosine, in between the middle and the last, that's where we hit the midline. And for sine, that's when we drop down below. So sine looks like this. Cosine looks like that for one period. Okay? So, that's what everything is based off of. And we're going to adjust amplitude, the period, the midline. Remember, midline shifts it up or down. Period either stretches it out or squishes it in together. And amplitude makes it taller and lower. Okay? Alright, so let's get to it. So number 3. We've got 2 plus 2 times the cosine of 4 theta. So, what we need to do is figure out what our amplitude, our period, and our midline is. Midline's easiest. It's a number we're adding or subtracting, so positive 2. So instead of a midline at the x-axis, my midline jumps up to positive 2. Okay, then my amplitude is also 2. So instead of 1, my amplitude is going to be 2. So for my graph, I go up from that midline 2 because it's cosine. So we start 2 above that. Okay. Then for our period, we take this 4, and that's not our period, but I go 2 pi or 360 divided by 4. Okay. If I did 360 divided by 4, we'd end up with 90 degrees. Okay. Which we can see because 2 over 4 becomes 1 over 2. So 1 pi over 2 is pi halves, which is 90 degrees. But generally we use the radians when we're graphing, so that means I'm ending at pi halves, and cosine ends where it starts. Okay, then I go in between those, right here, right? And now I'm going to go below to right there, that amplitude. And then in between the first and the middle, so somewhere around here, we're hitting the midline. And the same with between the middle and the last, in between we're hitting that midline. So we really squish this one in. So it'll look something like that. Probably should have written pi halves right here. Alright, so there's a cosine function. Now let's take a look at number 4. So amplitude is 1/2. Period is going to be 2 pi divided by 3. So 2 pi thirds, okay, which, if you weren't sure what it is, you could go 360 divided by 3, and that's 120 degrees, is 2 pi thirds. So this is 180, and this is 90, and this is 135. So it's going to be a little bit between right here. Okay. for my period. So 2 pi thirds. Then our midline is a -2. So we start off going down -2 for our midline. Then, with sine, we always start on the midline, so it's going to start right here. And we end on the midline. So I'm going to end at about 120, which is about right there. Now, because it's not lining up with the tick marks, now is kind of where I just estimate. So in between these two, I'm also on the midline. Now, in between the first and the middle, we go up our amplitude, which is 1/2. So I only go up about 1/2. And in between the middle and the last, we go down 1/2. So down 1/2-ish. And so it's going to look like that. So kind of a really small guy. We shifted it down to, scrunched it in quite a bit, and scrunched it in this way too. Alright, let's look at number 5 now. So an amplitude of 1/2, again, midline of -2, and a period of 2 pi divided by 4, which we know, divided by 1/4, because that's like 1 theta over 4. So it's like 1/4 times theta. So when we divide by 1/4, that's the same as timesing by 4. So we end up with 8 pi for our period. So we're going to stretch this guy out. So midline drops down to -2. Because it's a sine function, it's going to start on the midline. It also ends at 8 pi on the midline. And in between 4 pi, it's also on the midline. Then in between the first and the middle, we only go up 1/2. So at 2 pi, we're at 1/2. And then in between 4 pi and 8 pi, or at 6 pi, we're down 1/2. And so we look like that. Whereas the parent function would have looked like that. So you can see how different it is. Alright. Number 6, amplitude of 2, midline of -1, period of 2 pi divided by 3, which we did that one, can't really simplify it, so 2 pi divided by 3, which is basically 120 degrees. So midline, we bump it down 1. Then for sine, we start on the midline and the y-axis. And we also end at that, and so we're right about here. Okay. Then in between that, we're still on the midline. Then in between the first two, we go up to an amplitude of 2, so about here. And between the middle and the last, we go down about 2, so about there. So it looks like that. Alright. So let's just keep on trucking. So amplitude of 2, midline shift to +1, period of 2 pi divided by 4, which we know is pi halves. We've had that one show up a lot, haven't we? So, start at my midline up here. Start because it's sine right there. End at 2 pi halves right here. Halfway in between still, and those are off slightly, aren't they? Okay, then in between those two, amplitude goes up 2, and in between the last two, amplitude goes down 2. So it looks like that. Okay, number 8, amplitude of 1/2, midline of -2, and period, we just did it once, so pi halves. So start out at -2, then on the midline, then at pi halves, we're also on the midline, in between, we're still on the midline, then we go up about half and down about half. So, looks like that. Alright, now we got some cosine ones. So we got to remember the differences, right? Amplitude of 1/2, midline of -2, period of, we've got 4 again, right? 2 pi divided by 4 gives us pi halves. So midline at -2. Remember, with the cosine, we start at the amplitude. So I start up here at 1/2. I also end 1/2 above. In between, I go 1/2 below, and then in between and in between, we're on the midline, so it looks like that. Okay, again, amplitude of 1/2, midline of -2. The only difference is now our period. So instead of pi halves, it's 2 pi divided by 3, so 2 pi thirds. So midline down at -2, amplitude up 1/2 above it to start for cosine. Then we end at 2 pi thirds, which is about right here. In between those two, we go below 1/2. Then we in between first and middle on the midline, middle and last on the midline as well. So it looks like that. Very similar, just different periods. And you can see how that kind of stretched it out a little bit. Alright. Number 12, amplitude of 4, period of 2 pi divided by 4, which is pi halves, and midline of 1. So we busted up 1. Then we go 4 above the midline, up to 5 to start. That's also where we end at pi halves. Then in between that at pi fourths, we go down 4 to -3. And in between the first here and the last, somewhere on that midline. And in between the middle and the last, we're also on that midline. So it looks like that. Bigger amplitude makes it look quite a bit different. Okay, number 11, amplitude again of 4. Midline shift of 2, so we're busting it up 2. And a period of 2 pi divided by 2, or 360 divided by 2, right? If we were doing degrees, which would be 180 degrees. We also know that as pi. So starting me off, we start 4 above the midline, so up here at 6. We end at our period pi in the same position. In between that, pi halves, we go down 4 to -2. And then in between 0 and pi halves, we're on the midline at pi fourths, as well as pi halves to pi at 3 pi fourths. And there's our cosine function. Alright, so now they want us to, for these 4, create the function. Okay, so we need to find the amplitude, the period, and the midline. Okay, the same information, and we're going to use it to write that parent function of the amplitude times the sine of b times x plus the midline. Okay, so the easiest way to find the midline is go from top to bottom, cut it in half. So pretty easy to see that my midline is right there. Okay, again, top to bottom, then cut it in half. So from 4 down to 2 would put us at 1. Okay, so over here on 13, k would equal -1. On 14, k would equal +1. If we look at 15, you can definitely see it's right there. K equals 3. Here, k equals -2. Then the amplitude, just go up or down. So we see that that amplitude is 2. Just up or down, so 1, 2, 3. You can double check. 1. And finally, also 1. Okay. Now to find the b, we need to know the period, don't we? Okay. So we know that these are sine functions. So sine functions starts and ends on the midline. Okay. So if if I look right here and I start on the midline, now there's a few different ways we can think about it, because sometimes they can be flipped. Okay, so instead of, normally we go up and then down, so this one's going to have a negative out front, okay, because it's flipped. Same with this one. So, but we go down, see how far it takes us to get there. So this one has a period of pi. Okay, so we know that 2 pi divided by b is going to equal pi, so we're going to have to do some figuring out here. Okay, so I can multiply by b on both sides, so I get 2 pi times equals b times pi. So divide by pi, and we see that b is going to equal 2. Okay, so I don't actually need the period in my equation, but I do need the b. Okay, so again, starting right here, takes us till we get to there, takes us 4 pi. So the period is 4 pi. So I know that 2 pi divided by b equals 4 pi. So I times both sides by b to get 2 pi equals 4 pi times b. Divide by 4 pi. Pi's canceled. 2 over 4 becomes 1/2, so 1/2 equals b. Again, I don't need the period, but I do need the b. Okay, from this one period goes to 6 pi. So again, 2 pi over b equals 6 pi. You can kind of see that same pattern, times by b. 2 pi equals 6 pi times b, divide by 6 pi. Get 2 over 6, which reduces to 1/3. So my b is 1/3. Oops, third. Okay, and then the last one, another negative one like we said. Go down till we hit there. So that's 2, a period of 2. Now there's no pi here, so 2 pi equals 2 over b. So I'd get 2 pi equals 2 times b. Pretty easy to see when I divide by 2 that b equals pi, which is alright for it to be written as a radian. Okay? Alright. So now we can write the equation. So for 13, I go y equals, and because it's flipped, I'm going to put a negative out there, then my amplitude 2 times the sine of my b x or b theta, and plus or minus my k, minus 1. For 14, y equals my amplitude 3 times sine of b is 1/2, so 1/2 x, or I could go x over 2 or theta over 2. I like the 1/2 x plus 1. 15, y, or f of x, I guess I could have been writing f of x, y equals amplitude of 1, so I don't necessarily need to put the 1, but I'm going to, sine of 1/3 x plus 3. And 16 becomes y equals 1, negative 1 because it's going the opposite way, times the sine of pi x minus 2. And there's our 4 equations. Okay, now we're going to do the same exact thing, only with the cosine. Okay, so we're going to find, again, the amplitude and all that stuff. So we want to start with the midline. I don't know, I wrote that weird. Okay, so top to bottom, cut it in half, -3, +5, should be going down to 1. Okay, so k would equal +1. Now I could do the amplitude right away and realize that it's up 4 or down 4, so my amplitude would be 4. And then my period, remember we start at the amplitude till we go back through, so my period would be 8. So what would b be? So I go 2 pi divided by b equals 8. So 2 pi equals 8 times b. Divide by 8. and I would get 1 pi over 4 for my b, or pi fourths. So pi divided by 4. Okay. And then with that, I could write the equation. Okay, I'd go y equals my amplitude times the cosine of pi fourths x plus 1. So I can do it like sine, or I can do it like cosine, where I take the information one at a time and do it, or the whole time. Okay, so 18 definitely right there for our midline, so it's 0. Okay, but we don't go plus 0, we can just leave it off. Amplitude of 2, easy to see. Period of, starting up here, until we hit back up there, and it's a period of 2 pi over 3, which we've dealt with that, so we should know what the b is. We've seen that one. But if not sure, 2 pi over 3 equals 2 pi over b. Well, pretty easy to see what's going to happen, right? The only way for this to work is for that to be 3. Could I multiply by b and then divide by 2 pi? Yeah, but I might as well leave it like that. So y equals 2 times the cosine of 3x, because we don't need that. And then I could do plus 0, but I don't need to. So I'll just leave it like this. Okay, number 19, top and bottom, so it tells us we're going to have our midline right here at -3. Amplitude, we're going up 2 and down 2. Period, now we're starting below, so that means this is going to be negative. But from one to the other, period of 2. So for b, we kind of already dealt with it right here, right? When our period was 2, b ended up being pi. But again, we go 2 pi over b equals 2 times by b. 2 pi equals 2 times b, divide by 2, and yes, pi equals b. Okay, so because it's flipped, I know my amplitude is really going to be written negative. So -2 times the cosine of pi x, then minus our k, minus 3. Okay, last one on this. Definitely see it's right there at positive 3. Amplitude, we can see it's going up or down 1. Okay, we can see we start below the midline, so we know it's going to be a negative, right? But we go from here to here to 2 pi. Okay, so our period is 2 pi, which means that our b has to be 1. Because 2 pi over b equals 2 pi. Only way it can work is if it's 1. Okay, so I go y equals -1 times the cosine of 1x plus 3. Alright, now let's take a look at these last problems. We're going to use this story problem and graph to solve. So we've got the average monthly temperature in Swansburg. Okay, the temperature as seen on the y-axis, the month on the x. We can see we've got a periodic phenomena going, which makes sense with temperature, right? Except for this month. Here, when Eve released a spring, it completed 1 oscillation cycle per second and traveled up to 4 inches. Okay. Oh, I guess this only works for number 22. Sorry, so we'll just we're writing the equations. So we need again to find the A, the K, and the B. So when Eve released a spring, it completed 1 oscillation, 1 cycle per second, and traveled up to 4 inches from equilibrium, its midline. She knows the oscillation can be described by a cosine function with no horizontal or vertical displacement, meaning k is 0. Write an equation to describe this function. So k is 0, which means it traveled up to 4 inches, so that's our amplitude. Okay, and it completed 1 oscillation, 1 cycle in a second. So our period would equal 1. So we'd go 2 pi over b equals 1. So b would have to be 2 pi, right? So in my equation, they said it was cosine. So it would be y equals 4 cosine of 2 pi x, or theta, and then plus 0, so just leave it like that. Okay, Brandon played a note on his clarinet that had an amplitude of 2, well that's easy, and a frequency of 740 hertz. Now we haven't dealt a whole lot with frequency, but it is connected to period and to B. To the frequency, it's equal to B over 2 pi. He knows this note can be described by a sine function with no horizontal or vertical displacement, so k equals 0 again. Write an equation to describe the function. The reason k is 0 is often in real situations we don't displace it above or below. We just leave it how it is. Okay, so a frequency of 740, so 740 would equal b over 2 pi. So I go 740 times 2 pi, and we generally like to leave the pi in there, so I'm going to go 1480 pi equals b. So we could find our period, but we don't need the period, right? And these are the few cases where we actually need the frequency to find the b. So it's 1480 pi. So we go y equals 2, and it's a sine function, times the sine of 1480 pi times x. And that's our equation. Okay? So that frequency, remember, we talked a little bit about it, but not a whole lot. This is kind of the few situations where you may need it. Okay, 25, last problem here. Since January 2005, the average monthly temperature of Swansburg, temperatures, I should say, of Swansburg have fluctuated in accordance with the function shown in the following graph. Write the equation. So again, what's our amplitude, our midline, and what is B? Okay, so if we look at this, okay, we can see that we're not starting at the midline, right, or exactly below. So the midline looks to be about right here, right? Or am I off by 1? See, 1, 2, 3, 4. 1, 2, 3, 4, 5. So it's going to be in between. I was a little off. So it'll be at 15. Because, I guess I was counting by 2s. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 up. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 down. So amplitude of 9. Midline of 15, positive. Okay, now we find the period. So the easiest way is to probably look and see from one point to another. So the period here goes down and then up. Now you could actually come up with a lot of different equations depending on how you start. And it looks like this has a horizontal shift by 1. So I'd probably start it right here and do it to right here. So that would be 13. And down here would be at 1. So the period would be 12. So the period of 12, so we go 12 equals 2 pi over b. So 12b equals 2 pi. Divide by 12. We end up with b equals pi over 6 when we reduce. So pi over 6 here. Because we started below, we know it's negative and I only have a minute left. So it's going to be a cosine. Now, because it shifted over 1, that actually adjusts things slightly. Generally, we don't deal with shifts. So for us, I would just be happy if you got negative 9 cosine of pi over 6 x plus 15. But in this case of it shifting, the shifting actually would be like y equals negative 9 cosine of pi over 6 times x minus 1 plus 15. Okay, now you could make a sine function and shift it even further when you get that horizontal shift in. That really throws things off. But I'm happy with this or this one. Okay, so there we go, guys. There is that practice for us. And now we'll just let the time run out.